Let's explore some basic functions and their graphs. First, the identity function, defined as f of x equals x for all real numbers. Both the domain and the range are the set of all real numbers. Next is the constant function, defined as f of x equals c, where c is a constant. The domain is the set of all real numbers, while the range is simply the set containing only the constant c. For example, f of x equals 3. Its domain will be real number, and range will be 3. Polynomial functions are defined as the sum of terms with non-negative integer powers of x. Here you can see examples of different polynomial graphs. Here you can see the graph x squared minus 2, y equals x cubed minus x squared plus 2, and the graph of x to the power 4. Rational functions are expressed as the ratio of two polynomials, that is, f of x by g of x, where the denominator cannot be 0. For the basic function 1 over x, the domain and range both exclude 0. Here you can see the graph of y equals 1 by x. The modulus function, or absolute value function, returns x for positive values and negative x for negative inputs. Its domain is all real numbers, and its range is the set of all non-negative real numbers. The graph of mod x is v-shaped. The signum function outputs 1 if x is positive, 0 if x is 0, and negative 1 if x is negative. It is also defined as the absolute value of x divided by x. See the graph of signum function here. The greatest integer function, often called the floor function, maps any real number to the greatest integer less than or equal to that number. The domain is all real numbers, and the range is the set of integers. See the graph here. Conversely, the least integer function, or ceiling function, outputs the smallest integer greater than or equal to x. Like the floor function, it has a domain of all real numbers and a range of integers. The fractional part function is defined as x minus the floor of x. It has a domain of all real numbers, and its range is the interval from 0 inclusive to 1 exclusive. That is, range is 0 to 1, but 0 included and 1 excluded. You can understand it with the help of graph. Exponential functions take the form a to the power of x, where a is positive and not equal to 1. The domain consists of all real numbers, while the range is restricted to all positive real numbers. The logarithmic function, log base a of x, serves as the inverse to the exponential function. Here, the domain is restricted to positive values of x, while the range covers all real numbers. Now let's learn graph of trigonometric functions. The sine function has a domain of all real numbers and oscillates within the range of -1 to +1. You can see the graph of sine x. Similarly, the cosine function also has a domain of all real numbers and a range of -1 to 1, though its graph is phase-shifted compared to sine. The tangent function has a restricted domain, excluding values where the cosine is 0, which are odd multiples of pi over 2. Its range, however, includes all real numbers. Finally, the cotangent function excludes integer multiples of pi from its domain, as these points result in a 0 denominator. Like the tangent function, its range is the set of all real numbers. Moving on to the secant function, it is defined as 1 over cosine. Its domain excludes odd multiples of pi over 2, and its range is the set of all real numbers with an absolute value greater than or equal to 1. The cosecant function, or 1 over sine, has a domain that excludes all integer multiples of pi. Similar to the secant function, its range is limited to values where the absolute value is at least 1. Next, we explore inverse trigonometric functions. The inverse sine function, or arcsine, has a domain of -1 to 1 and a range restricted to the interval between -π/2 and π/2. The inverse cosine function, or arccos, also features a domain of -1 to 1. Its range, however, is defined on the interval from 0 to pi. The inverse tangent function has a domain of all real numbers. Its range is bounded between -π/2 and π/2, non-inclusive. You can see it in the graph.
Similarly, the inverse cotangent function has a domain of all real numbers. Its range spans the interval from 0 to pi, exclusive of both endpoints. Look at the graph of inverse cotangent function.
The inverse secant function accepts inputs with an absolute value of 1 or greater. Its range is from 0 to pi, excluding the value of pi by 2. Finally, the inverse cosecant function also requires an absolute input value of at least 1. Its range covers negative pi by 2 to pi by 2, excluding 0. Look at the graph.